So this is a new video here. I just spent the past hour and a half going through how to install Anaconda and so forth. Going to realize that I wasn't sharing the screen with Anaconda. So I'll just briefly go through how to install Anaconda. So how I found Anaconda, I typed in Anaconda here, and then we saw two versions. I click this one, I click this one. Like this one, free download, click this one. I'll go to this one first. So apparently, there's some new version of Anaconda, Meet Anaconda Assistant. It has some AI version. I do not know anything about this AI version, so I'm not going to interfere with this. I'm going to go to it. I will go to this version. This is the free download here. I'll click this, and then I'll download. But I already have the program, so I'm going to cancel it. I don't want the program. I already have the program here. I guess I can create another video that shows you in detail how I want to install Anaconda, but I already installed Anaconda and I'm not going to go through that. It's very simple. Just follow the steps, click, 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 and install the software. So after we get Anaconda, this is how the Anaconda navigator is going to appear. So what Anaconda is, it's a program and it has a series of other programs in it. So the program that we really want is Python. Well, the program that I really want is Python. Another program that I like to use is Visual Code, that is VS Code here. And that's what I want to do web page design and so forth. But for econometric model, I use Python. Now, one time for econometric modeling, although I use Python in conjunction with other programs. So I want to use Python with Notebook. So if you look here, we have Jupyter, we have Qt console, and we have Spider. What I know for certain is that Jupyter Notebook, Qt console, and Spider, all these three programs can run Python to do different modeling and analysis and so forth. Basically, Python is the program in the background, and in the foreground, we have a GUI type interface. When I say GUI, I mean graphical user interface. This looks relatively pretty. It shows some icons, shows arrows, and so forth. And it's better, it's more user-friendly and easier to use and navigate and so forth, as opposed to when you're trying to run programs in pure Python, you get a black interface, like a command prompt interface. It's going to look black. It doesn't look pretty at all. If you want to look the command prompt interface, you can use this here. I think this is it here. This is how we want to look here. I mean, we're going to use this if you want to just use pip. We're going to pip installs different packages and so forth. But you're going to stay away from this. I rarely use this for Python. I use Jupyter Notebook. Of course, Qt console could work, Spider could work also, but I'm not going to use these things. I like to use Jupyter Notebook, so I'm just going to go straight to Jupyter. So click here, launch. So when we launch Jupyter, it looks up like this. If you check this open up in a browser, this open up in Microsoft Edge browser. At least with my computer, it always open up in Microsoft Edge browser. It never open up in Firefox, it never open up in Chrome. I don't know why only Edge. Maybe it could work in some other application like another browser, but it works. And my sole objective is to run Python to do different analysis. So I just run on this and I don't really pay attention to those nitty-gritty details. So we want to run a model, and yeah, many models we can run. We can run an OLS, we can run an Arch, we can run a Gach, we can run an EGACH, we can run a PAL data model, we can run fixed effects, random effects. We can use a co-integration model and so forth. There are a lot of models we can run in time series econometrics. We're going to start with a basic model, an OLS model. OLS, ordinary least squares. That's the first regression you learn in econometrics. Basically, a linear regression. So basically, you have a series of data points. You have data points going up, data points going down, scattered all over the place. Basically, what an OLS regression does is plots a straight line going through all the data points and tries to minimize the error on the data points. When I say minimize the error, so you're on a regression through all the data points, trying to get the best fit. Now, You're trying to get the best fit, but not every single data point will fit exactly on the regression. Some data points will be above, some data points will be below. You can have a positive error. That's where the error, it doesn't, so it's not exact. So there's the difference between the actual value and the estimated value. They might have a positive error, or sometimes you have a negative error where you come like um the actual value is below and the estimated values are above here. So you have a negative error here. So you have positive errors, you have negative errors, but you're trying to run a regression that trying to minimize the sum of the square of the errors. There's a long mathematical proof for this in econometrics. I'm just trying to get straight to the point um, about how to run this in Python. So I'm already assuming that you already know the different models. You can read the econometrics textbook, or I could do a tutorial later on that explain these models in detail. But for the time being, this is just exercise to show you how to run the models in Python. So first, we're in Jupyter Notebook. Then click New, Python. And a new notebook will appear. Now, I was already working on a notebook here, but the problem was that I made a video already, and only after I made the video, I realized that the screen wasn't sharing. I had the wrong screen share. So it wasn't actually seeing all the different things that I did. So what I'll do, I'll copy over some of the code, and I'll create it, and I'll put it, paste it on this new worksheet here. So when you're running Python, you need to install libraries. Libraries is like how I can see is like literally a library, right? So it's like a collection with information, a package of information, and it has all the commands to do specific tasks. So since the library we want is one for data, will be a group with a series of commands with how to manage data. So this is library that we are importing here, pandas. Type in pandas is a library for data management. Now, this is the actual code here. Import pandas as PD. So import is the command, what we actually telling Python to do. Import. What to import? Import this library. Pandas. We need to import it as something. We say we importing pandas as PD. So anytime we type PD, we are telling Python that, hey, we want pandas. If you can see here, I typed in a number sign with the pound sign here. Pandas is a library for data management. Basically, what I put is a comment, and what this comment is doing is explaining to me what this code is doing. So let's say some time pass, some months pass, maybe a year, 2 years, 3 years pass. I want to run back this code, and I can't remember why the code is running. Well, the, the comment will explain to me what this code is doing. So when I want to run the code, I can just read the comment and say, oh, this is what this code does. So I click run. So anytime you want to run a code, it's two things you could either do. You can either click run, or you can highlight the code and press shift and enter. But in this area here, we're just going to click, in this instance here, we're just going to click run. So code has run. The next thing we're going to do is going to import data. Now, originally, the data was like this, right? Let's see the original data file here. The original data file was df pd read excel c users action download whatnot. this was the path directory for the data. But when I was made it, but in the previous video, I realized there was an error. I tried to run the model and the model wasn't running. Data wasn't important. Why the data wasn't important? Because the path directory was changed. When originally when the data was run, the data was stored on a drive called the C drive. Now the data is now stored on a drive called the F drive. And because of that, the data run in the past and not run in the future and not run in the present. So we had to actually fix this. Well, I already fixed the code. This is the fix here. The fix is to change the code to F. Let's just run that C. You will see it wouldn't run. See, the code wouldn't run, got a big error. Now, if you change to F, the code will run because this is the correct code. This is the path directory where the code is saved. This is the code here, TF. So we are calling the data series, the time series, TF, PD, pandas. Remember, every time you see PD, that means pandas because we just import the library as pandas. And this is the command, read Excel, because it's an Excel file. Or if it was a CSV, it will be read CSV, but the file is saved as an Excel file. So you say read underscore Excel, and this is the path directory to the file. The next thing you want to do, if you want to see the time series, well, you want to see the data that we just imported. So just press enter. Actually, you just press run. And this is the data set here. So you can see this is the rows. No, this is the rows here. This is the columns. You can see it has 225 rows and 3 columns. 1, 2, 3. 1 column for date, 1 column for WTI oil prices, West Texas intermediate oil prices, 1 column for returns. I want to share the screen. I'm going to show the data. This is the data file here. Yes, 1 column for the date, 1 column for the oil prices, West Texas intermediate, 1 column for the returns. When you scroll along, there's actually 225 rows. Now, actually, all we're seeing here, 226. If we scroll up here, we see we actually start counting from 1, from date. So if we delete, and then go back down, you can see it's actually, in terms of rows of data, is 225. So undo. Screen share. All right, so I'm back to the data file here. Now, suppose that we are running this time series and we wanted to, like, let's say, wanted to drop this column here, the date. This is the command to actually do it. And how I remember this command for certain is that I have instructions here. I actually put a comment. If I wanted to drop the name index, I could type and press enter. Well, press run. So now press DF. Run. You can see the date column is dropped. If we want to show the first 5 rows of the data set, we could type in this. Run. This will show the first 5 rows of the data set, right? Now, if we want to show more than just 5 rows, let's say we want to show 6 rows. Change 6. Go here, run. Now you can see here. Now what we can see from this exercise, right? We're running code line by line. You can run all the code at the same time, but I'm going to run this code line by line specifically for this exercise. If you want to change, if you want to show the first 7 rows, type in, change from 6 to 7. 1, 2, 3, 4, 5, 6, 7. See, we have seven rows. Everyone see the first 10 rows? See, we have 10 rows now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's change it to. See, we have only 2 rows here. So let's change back to 5. And the reason why we're sticking with 5 is because 5 is standard. I mean, a lot of people, researchers, when they're running these different models on Python, so when you do data science, I want type df head and I want to display a time series. Usually they do put just want to see first 5 rows, so I'm just sticking with that because that's just standard. But you could choose a number that you're comfortable with. This is just a visualize the data. We really start the action. Um, the next thing I'll do is print the shape of the data. Tell me how much rows, how much columns. So if you could see here, the command is print. This is the command, and we have a brackets here. Brackets, open brackets, close brackets. This is in the commas here, the inverted commas here. This is what we wanted to print. We wanted to print shape of data. Let's say we want to change our shape of data to say Pac-Man. You see, it changed from shape of data to Pac-Man. Say shape data. See, so to print this shape of data, this is 225 rows and 2 columns. If you just want to see the F shape, so you don't want to see this word shape, you don't want to see this phrase shape of data, you just want to see the F shape. I want to highlight this. I press Shift and Enter. Remember, we click Run, or you press Shift and Enter. So it gives us the number of rows and columns, the F shape. So the next thing we're going to do, we're going to import another library. We're going to import a library to deal with graphs. Library we're going to import to deal with graphs is matplotlib. That's library here. Press run. See the code is working. How you know the code is working is that we're not getting any error messages. Next thing we are going to do, we're going to import another library to deal with numbers. The library we're going to import to deal with numbers is numpy. So the command is import numpy as num. So if you realize every time we import a library, you need to say import, you put the library name, put as, and then you give that nickname to how to import the library. So you can see for NumPy, the library is, we call it nickname as num, N-U-M. For Matplotlib, the library was PLT. For Pandas, the library was PD. Now, I'm going through this in detail because I want to run an econometric model. But when you're doing let's say, a course in data science, all you're going to do is add, subtract, multiply, divide, multiply this row by that row, and all these kind of different things. If you want to do a data science course, you'll do these things, but I want to run an econometric model. A data science course that you will do will not teach you how to pull time series data on oil prices, gas prices, GDP, import, exports. And now going to teach you how to deal with these different time series data, these real life time series data, and run a regression on it. You have to learn this on your own. Asta. So I mean, oh, you have to watch a YouTube video. Somebody has to make a video and show you or some cartoon like this now. So this is what I'm doing here. I already know how to do this, so I'm making a video showing how to run regression, time series regression, for econometrics in Python. And I like to use Jupyter. The same thing we do in Jupyter, the same thing could be done in Spider, but I like to use Jupyter. I just comfortable to Jupyter, so I use it all the time. Think around this already. This code, you're just going to print columns. So this will print the different columns you have. So you have two columns, index. The two columns are WTI and returns. This is one column here, WTI, the other column is returns. All right, so the next thing we're going to do is plot the data. Now, to actually plot the data, this is the first code I actually found to actually plot data was this code here, figure plot. So we are calling matplotlib when you type in PLT and press enter, well, press run, but nothing appears because we didn't tell it what to plot. So let's give it information to plot. This is a plotted graph of the data. And click run. We have an error. Something is wrong. Now I do this deliberately, right? I do this deliberately because I actually know how to correct this problem. So I want to make it, I want you to observe. So we run this model, we have an error. We know we have an error here. Something is wrong. What is wrong? Something is wrong with this code. So, but we see in our graph here. We see in our graph, and we see something. All right. So we know when you run figure, when you type in this code, figure plot, we know PLT from matplotlib is working. We know it is working for sure. And we know that the plot command is working because we get plot something. Well, we actually get a plot, a blank graph. See the x-axis, we see the y-axis, but we saw nothing inside it because we put no data in it. So we know this command is working. So let's see the code, what the code is looking. So let's look at the title. By the title, we want to put this command here. This command, ax set title underscore title, WTI prices weekly. Let's see if this is working. All right. So this is working. So we know this code is working. We know this part is working for sure. So let's look for the labels for the x-axis and the y-axis. This is the label the x-axis and the y-axis. Now, I know this label the x-axis and y-axis because how I wrote the code, I explain my code in details. I put comments and I explain my code in detail. So I know this was right for the x-axis and y-axis. Let's see if it's working. All right. The x-axis is date. The y-axis is US dollars per barrel. So we know this is working. So this is working. This is working. This is working. Now let's look to actually plot the graph. So this is the time series one. The time series you're looking at is WTI. And the next thing we're looking at date. And the color gonna be red. Let's see if this is working. That's not working because we're not seeing anything there. So apparently this part of the code is working, this part of the code working, this part of the code working, but when it comes to actually plotting graph, that's not working. So something had to be wrong with the code here. You know what's the problem? The problem was up previously here. When we applied this code, we applied this code in line 5, we drop the date. So now the time series now, in terms of data set, when it's reading DF, it's showing two data sets. It's showing WTI, it's showing returns, and actually showing the dates. Somewhat of a problem. So you know what to do? I'm going to delete this. I'm going to go back up here. I know the problem had to be when we drop this date. I notice the problem is when you apply here. So what we want to do, we'll go back here and we import the data. So click here, run. So now this is the time series. Click run. This is going to be time series here. So we're going to have 1, 2, 3. And I want to go back here and run over this. Basically what we did is that we undo the effect of this here. You see, when we apply in line 5 here, where we drop this state, we undo that effect just now there. So when we re-import the data, we undo that effect there. So now we're going to run back the time series, and when you try to plot the graph, it's actually working. So that was the problem right there. And this is the problem when you're dealing with a lot of these different times and so forth, right? If you realize here, the date kind of jumble up. The date really plot all that good, but you could fix that thing. But all right, this is code how to fix it. Basically, how you fix it is that we're making the figure a bigger size. This was the code here, pick figure size 15 by 15, 15 by 5. Let's click and run. All right, so let's say 20 by 5. 20 must be the length. Yeah, 20 is the length. So let's say 15 by 10. 10 will be height. Yeah, XY. Yeah. So this is X, this is Y. So I go back to 15 by 5. So this is how we basically adjust the code. We adjust the code by adjusting the figure size. Go work with that. I don't need to worry about that. I know the code working. All right, so this is a basic transformation. If you're doing, let's say, if you don't have course in Python, they'll make you do a lot of different transformations, add, subtract, multiply, divide. So I did a basic transformation. I divide the WTI data by 6 because I assume terminal parity. Um, that terminal parity meaning that in terms of the entry content or so forth, is 6 times the ratio is 6 to 1 for oil to gas then. So 1 barrel of oil have roughly 6 times the energy content of gas or some kind of thing like that. So that is the basic thermal parity. So what I did, I divided up the I by 6. Did I get like DF brackets? So while like sometimes you don't even need to type out all the code. The code is typed out for you. So if you look, I just type in a brackets and the open brackets and the closing brackets appear. I know Jupyter does this, Spider does this, and I know Visual Studio Code does this also. So I mean, I like the software. I really like the software because of that. So you see Henry Hub. All right. So you know it's working. This is the view the first 7 values. You know, let's shift from 7 to 8. And let's change it to 2. And I'm doing this deliberately because you can see when you're running models, you need to be able to understand what you're doing and know where to change your code. Note that I have plenty of code. We type in all this. We don't need to change all this. We don't need to change this value right here. The head. We want to just display 2 rows. You need to understand your code and you need to understand what your code is doing. And this is what we're doing right here. 2. Changes to 5. I want to display 5 rows. And this is a plot multiple time series on one graph. I know the code is working, eh? And if you realize, I just copy and paste my code, right? So my data, so if I work on a different time series, like we say I have this time series here. This code could work for you. So although I have oil prices here and I have gas prices and I have returns, this same code could work for you. The only difference in my code and your code will be the data. All you need to do is either do two things. It's either one, you change your data file. So you use back my same, you use the same code and you change, you go in the Excel file and just change the numbers itself in the Excel file, or you call your Excel file a different name. Well, I use DF. So I use like, let's say DF, and my DF have oil prices and returns. But you could use this like, let's say, stock prices and exports. And so when you load your DF, you will see stock prices here and exports. The code will work the same way. The only thing difference will be the data. So, and this is why you need to understand what you're doing, because it's the same. I don't need to change every single thing when you're in a code. You just need to make slight changes. You need to understand what you're doing, make slight changes, and the code will work. Click run. So you see the oil prices here. The oil prices is red. The gas prices is blue. We know for certain is that we plot WTI as red. We plot Henry Hub as blue. All right, this is a plot multiple time series on one graph. So you have figure, plot. So this is the command here, figure, plot, figure. Remember, this is the command from matplotlib. This is figure. So once you type in this figure, plot figure, we know a figure will appear. This is for the title. You need to put an axis, plot axis. This plot is matplotlib. This is the axis command. And this set title. This is what we set the title to be. So what's going to be in inverted commas here will be the title. This is labeled the x-axis and the y-axis. Remember that. Plot x-axis, date, font size 12. Let's change the font size to maybe 10. That's right. All right, let's 10 kind of close. Let's change font size to, I put a big font size, boy. I put 17. See how big it is? Let's put 22. See how big it is? See how big date is? Let's change the font size to 40. So you want to see the difference in the font size. Remember, this is the label, right? You see how big the date is? See how big? Because you change the font size of 40. Now let's change it back to 12. See, it becomes small. Let's change the font size here. Yeah, just need font size for the Y label here. That's this. Let's change this to 40. So you can see the difference. See how big it is here? Change it back to 12. Um, let's adjust the figure size here to 15 by 5. Like the same code like we used before. So I think we up here. So I need to figure plot figure equal figure size. All right, so if you look at this code here and this code here is very similar. The only difference is that in figure it have a figure size. So you can hit this. I'm going to put it inside figure. And then you're going to delete this. And then go click run. Something was wrong. Oh, I think we put two brackets in. You know what I will do that? I'll just put this run. All right, this is working. 15 kind of wide. Let's put 12. I put 10. No, this was the code that we had previously, right? This code, we just had this code there, but I didn't really want to disrupt this code here. So I put a number sign there just for me to keep it there so I could see it when I want it. On there. I'll leave it as is. Um, yeah, what I'll do. I'll copy this, paste this, the number sign, and then go in here. Click run. So if I want to resize the figure, I will just type this. Let's go here. Just go there. Put number sign there. Click run. Get bigger. And if I want to just get smaller, run. So, but I know what I'm doing. So anyhow, um, so we are going now to prepare and run the regression. I want to end this video relatively soon, but to run the regression, I need to import a library. The library we're going to import to actually run the regression is called stats models. So import stat models at stats1. Stat models libraries to run the regressions. Yeah, happening. I am going to import all these things. I know these things working. I'm going to import all these things one time. So we are going to import stat models. We need to import stat models API as SM. This is our next library we need to import. From stat models, we need to import the array model. We import that array. From sklearn, we need to import mean squared error. That's to determine the error, mean the average of the squared error. That's what mean squared error is. And from math import square. Let's see if this will run. Yes, this run, no errors. And now we will run the regression. Run, see it run, no errors. And now we will just print the summary. Run. So the model has run, but you know this model is terrible. Why you know for certain? Just look at the R squared, right? The R squared is perfect. The R squared is 1. So this giving up. Oh, I could see why. You know why? It's because WTI and Henry Hub. The only difference in WTI and Henry Hub is 6, in the sense that we divide we divide WTI by 6 to derive Henry Hub. So that's why it's going to be a perfect fit, because there's a the relation between, there's a perfect relation between WTI and Henry Hub for every observation. That's why the fit of the regression will be 1 because we divide by 6. If we divide by 10, we divide by 15, we divide by 22, or there's it's always going to be the same. So the WTI line will be parallel to the Henry Hub line, and the model is actually picking up this. Hence the reason why the fit of the regression is going to be 1. Um, if you look at the what is coefficient? Well, the coefficient here, the coefficient is 6. You see it? The coefficient, the probability and the statistic, so it's statistically significant. It must be statistically significant. It must be statistically significant. Why? Because that perfect fit. Yeah. And so forth. So this is the regression right here. This is just a basic regression. We can add in different variables and run regression, but we know for certain that we can run regression. So before we close, I had in my code here another way to actually how to specify the regression model. So how this technique was to specify the dependent variable, specify the independent variables, and then to run the dependent variable on the independent variables. So I do that. And let's see if it's the same thing. Yes, I can spell the same model. So if you look at this code and this code here, it's basically the same. You know? Linear model. Well, the difference is that this one was linear model. This is the one we call the model. This was called linear model 1. We put type in this model linear model underscore 1. SM to that's a call for start models. Start models is package library. OLS, we want to run this regression. Colon for y variable and x variable. Y variable and x variable. And if you look here, this was the y variable, df brackets WTI. But this one specifying y variable and x variable. And in the previous code, we specify what is the y variable and specify what is the x variable. So you can specify the y variable and then x variable and then run regression as the OLS on y variable and x variable, or you can run regression like this, and then you can actually put in what is your y variable and then put in your x variable, which is very practical because you could change around. You could make Henry Hub now the because again the y variable. I can make WTI the x variable, and then run regression. Next part of the variable is fit. Next part of the model is fit, and then print linear model summary. Same thing like up here. Run. Same results. Create an area. Let's create a new variable. So create a new variable called lng. This lng is equal to the WTI variable divided by 6. We know WTI divided by 6 is really Henry Hub. Minus 2, and then multiply by 2. This is a basic transformation, but when you do the transformation like that, the lng will be related to WTI, but it will not be a perfect, the space will not be perfect for every single observation. So it will not be a perfect fit. Now let's run a new regression in a model 2. Brackets df lng it's run. We have a problem. Why we have a problem? Problem has to be somewhere here. Oh, this part can only run. The reason why it didn't run is because this code could only run it as a y variable and x variable. So we have to have one. So we have to have in the code one command for the y variable and one command for the x variable. And if you have more than one x variable, so if, let's say we have 2, 3, 4, 5 exogenous variables, you need to create a group specifying all the x variables and then run regression. So this is what we need to do here. I'll create my x variable differently. Let's see if this will work. Problem is how it is. Oh, this is the problem. The x variable 2 is not the same side. The problem is LNG. I need to fix LNG. The problem is LNG because this is not the same size. My endogenous variables matrix and the exogenous variables matrix is not the same size. might manually need to go and fix this. Anyhow, I'll fix this in the next video, but I'll end right here. So this is already a long video, but the channel is out here on a econometric model. You know what I'll do? I'll do this. I will, because I don't want to rest like this. I'll run this. I run a anyhow an LNG. I think the problem with LNG is different sizing. It run. This is statistically insignificant. No, it's statistically significant because this the probability of the coefficient. Yeah, the probability or the t value of the coefficient. The t statistic of the coefficient is equal to 0. R squared. This is still a very high fit, but not a perfect fit. The reason why this did not working is because when I specify this not for 3 variables is because of how I specify this variable here. I need to fix this. I need to fix how I specify the x variable for a regression, but I'll look into that. I'll fix that in the next video. So I'll end this video here.